Hello everybody and welcome back. I wanted to give a short update regarding the bad6502, and well, I've done some changes. I've made it smaller. Now it's just a Raspberry Pi hat, and it fits on there really nicely. So just pop it on. It fits the outline perfectly. I left the power in and the on-off switch at the back, and now you can have your 6502 directly on top of your Raspberry Pi 3 or 4. And also, this here is Raspberry Pi 4, and now I verified the code works perfectly with it, and I tested frequencies, and even with Linux running in the background on the Raspberry Pi, I was still able to get around 4 MHz on the 6502, and I'm pretty happy with that. And I'm probably going to go in the direction of having Linux as the back end for at least one of the things that I want to do. So I want to have a very simple emulation, simulation, whatever you want to call it, of the hardware, except the 6502, on the Raspberry Pi. And for quick startup times and super performance, I'm going to use the Circle library, well, Circle OS. And for a more mainstream approach, like with an integrated development suite and maximum hardware support, I'm going to use Linux as the back end for the Raspberry Pi. And I'm going to make a different user interface where you will be able to switch seamlessly between the 6502 and Linux. For example, you would be running a shell on the 6502, but you could still call an editor that resides on the ARM part, and from the editor you can use the included and linked toolchain to build 6502 executables directly on the same board, and then run them from the micro SD card, or maybe a hard drive, or a floppy disk drive, or the network. I think the freedom is a lot bigger the more powerful the back end is. Software running in 6502 mode will of course be running on the real 6502 CPU, and it will have all the limitations that the 6502 has. That being said, the approach is not so different than what other platforms are doing. And even back then, the Apple I was the 6502 connected to hardware for a terminal, and well, I get the terminal for free running Linux. So I think this will be a lot more flexible for the user and a lot easier to do development on, and it will be a lot simpler as an educational device, while at the same time being extremely powerful with the whole back end of a Raspberry Pi 4. And there are samples around there, like Element 14 has done an OpenGL graphics card for an Atari. The same thing would of course work on here, and being that we have the CPU on here and we can do all of the memory mapping and I/O mapping in the simulated hardware, this would be a lot more performant and also a lot easier to implement and explain. So I'm pretty happy with the hardware the way it is. I have another board in the making right now that is slightly different. It has a surface mount CPU and a 6522 parallel port controller, and that kind of works, but I'm still having problems with the I/O select logic that I also need to put onto the board, and it's just not ready yet. But I'm going to release this board soon, and then I'm going to rework the GitHub again, just to make sure that the development can go with 2 streams and not one as I had it now. Yeah, I think this is still a very nice thing. It is very much the hardware that I wanted to build. I wanted to have an 8-bit computer, but I wanted to have HDMI out. I wanted to have a USB keyboard. I wanted to have the option for a network or even wireless. So, from a cost standpoint, if you don't use a real Raspberry Pi 3 or 4, but a Raspberry Pi Zero, then we are still within the reach of the $50 price tag, which was another one of my design goals. And yeah, I'm pretty happy for that. So that was my update. I hope you have a great Christmas or season's end or whatever you choose to celebrate. I hope you have a good time, and thanks for watching, and bye-bye.